That'll do. I'm here to explain how to handle series of this nature. We are supposed to simplify and check for convergence of this series. Come with me, it's very easy, although it looks scary the way it is. Now we are going to pay attention to this part of it. Leave the series symbol outside yet. You're going to have 12 raised to power x over 3 raised to power x minus 3 raised to power x divided by 3 raised to power x, all that multiplying 3 raised to power x from the numerator. We do a similitude of that to the denominator too. We're going to have 16 raised to power x over 4 raised to power x minus 4 raised to power x over 4 raised to power x. Again, that should be multiplied by 4 raised to power x. So that if I effect the multiplication, I'm going to come back here. But there's a reason I'm doing that. Now, this causes this to give us 1. Such, this will also cause this to give us 1. We are left with these ones. Now, this one can be written as 12 over 3 all raised to power x. We know that this is now 1. And that is still multiplied by 3 raised to power x there. And over, again here, 16 over 4 raised to power x minus 1. Again multiplied by x raised to power 4. Now, we are here. If I simplify that, 3 cos 12 easily, so that I will have 4 raised to power x resulting in that minus 1 times 3 raised to power x, everything over, again, 4 cos 16 to give me 4. So our 4 raised to power x minus 1 again times 4 raised to power x, such that this causes this to give me 3 over 4 all raised to power x. As it is now, I'm coming back here, such that this will now become summation of 3 over 4 raised to power x. Mind it, our x run from 1 to infinity. Now, everything reduces to this. We've simplified this to have summation of 3 over 4 raised to power x, where our x runs from 1 to infinity. We are going to look at this. If I liter it, this would be equal to 3 over 4 plus 3 over 4 raised to power 2 plus plus 3 over 4 raised to power n plus . The ellipsis tells you that it continues indefinitely because it's going to infinity. But there's something of importance here. I can factor out the 3 over 4. If I do, I will have 1 minus 3 over 4, plus 3 over 4 plus 3 over 4 squared plus . It continues like that. 1. The 3 over 4 outside still remains, no doubt. But this is a series. A GP whose common ratio is 3 over 4. First term is 1. Common ratio is 3 over 4. And I know the sum to infinity of a GP whose first term is A, common ratio is R, is A over 1 minus R as it sums to infinity. I know that. Meaning that this will now become this 3 over 4 times A, which happens to be 1, and the denominator will be 1 minus 3 over 4. This is the sum to infinity. This is the sum to infinity of this series. If I sum it to infinity, this is what I should get. With the understanding that the sum to infinity should be A over 1 minus R, because our R is less than 1. Okay, that simplifies to be this 3 over 4 times 1 over, if I remove 3 over 4 from 1, I will have 1 over 4 left. And that will be equal to 3 over 4 times 4 over 1. If it's dividing that will equal. So that this caused this to give us 3. So this series, as airy-scary as it is actually solvable. If you simplify it, it becomes this. And if you sum it to infinity, it gives 3. Thanks for listening. See you next time. Thank you.